In this video, we want to describe the derivative as a function. So first, let's recall what the derivative is. So we introduced before this notation f prime of a. That's the notation for the derivative of f, the function f, at a. So the prime here means derivative. Now, there's two different ways of thinking about it. You can either think of this as the instantaneous rate of change at time a, or the slope of the line tangent to the graph of f at a comma f of a, or abbreviate this to be just slope of tangent line. Now, to understand these two things, to estimate them, we use this formula. In particular, if we talk about the instantaneous rate of change, that's estimated by the average rate of change over a very small interval that includes the point A. Or if we think about the slope of the tangent line, then that's estimated by the slope of the line containing a comma f of a and b comma f of b. That's also known as the secant line. In either case, what's important to estimate the derivative is this formula, the average rate of change formula, which is also the slope of the secant line. Okay, now we want to think of the derivative as a function. In particular, given any particular a, we can actually try to compute f prime of a. So that gives us a rule that assigns to every a an f prime of a. We can think of this in terms of machines. That is, we have a function f, and it accepts things called a's, and it outputs an f of a. Or if you put in a u into f, out comes f of u. Or if I put in a particular number, -1, then out comes f of -1. So f is a function, but f prime, the derivative of f, is also a function. So if I can plug in an a, and out comes f prime of a, the derivative of f at a. Or I can plug in -1, and out comes f prime of -1, or I can plug in another variable or expression, u, and get out f prime of u. So the derivative is a function just like f is, but it's a different function. Let's see an example of that. So here we have a graph, or actually a graph of two different functions. The function f is graphed in green, and the graph of its derivative, f prime, is in red. Now these are very different, but nonetheless they're related because f prime contains all the information about the derivative of f. For example, if I wanted to talk about the derivative of f at this particular point A, then what would that be? That would be the slope of this tangent line, the line tangent to the graph of f at this point. This point is the point a comma f of a. Now in terms of f prime, this slope is the actual height above the x-axis that's the height that's represented by f prime of a. So this height is f prime of a. So it's a little funny. When we think about the derivative in terms of f, it's the slope of the tangent line. But if you think about plotting the point a comma f prime of a, which belongs to the graph of f prime, this slope now becomes, that number becomes a height. So the slope of this line now becomes this height. And that happens at every point a. The heights of f prime, that is the height above the x-axis, corresponds to the slope of f. Okay, in future videos we'll talk about individual problems involving this concept.